today I'm going to talk about a concept area, okay? So we have square, we have circle, we have parallelism or diamond, we have triangle, right? We have trapezoid, right? So how to calculate the area for each one and what actually is area? Okay, what actually is area? So let me start it with Helen. You are younger, right? So Helen, can you tell me what is the area for a square?
Area for a square is like the measurement of the.
Measurement of what? I lost your voice. Hello? I cannot hear you.
Hello?
Hello, yeah. Repeat again. I cannot hear you.
So it's the face of the square, and it's the sides squared.
Size squared. Okay, good. How about Ethan? What is the area for triangle? Ethan, hear me?
It's base times length, base times height divided by 2.
Also half base times height, okay? How about this one, trapezoid, or this one for James? Hi, James. What is the area for this guy? Hi, James. Hear me?
It's the top top part plus the B1 plus B2 divided by 2 times height.
Okay, base 1 times base 2 times height. Okay.
Yeah.
Divided by 2. So how about this one, circle? Jonathan, you know circle's area? Jonathan? Give you a radius. So what's the area here? Jonathan, hear me? Jonathan, hear me? Let me see. Jonathan, hear me? Hello? Okay. Let me see. Jonathan, hear me?
Yeah.
Yeah, can you answer me what is the area for circle? Have you learned this before?
No.
No, you haven't done this one. Okay. The question will be, okay, then for Zoe, can you answer me what is the area for a circle? This one should be easy for you. So what's that?
It's pi r squared.
How about if you are given a area for a parallelism or a quadrilateral, how can you calculate area for that one? This one is harder, right? So what can you calculate area for this one?
Wait, is it for me or?
Yeah, for you. Yeah, for you.
Oh.
It's more or less.
Is it diamond or?
Any four side. You know, size 1, size 2, size 3.
I think I learned this before.
Yeah.
Isn't it like you put it in a circle, or you add up all the sides?
Mm-hmm.
Something. I don't remember exactly.
Yeah. So basically, there are some way you can cut it.
Oh wait,
you
you make triangles.
Triangles.
Right?
Okay.
Yeah.
That's actually what I'm trying to say here. So I give you different kind of the shape, and we try to calculate area, right? And then how about this one also for Zoe? This one is a little bit harder. So if we know the theta here, what would be area for this? Actually, this one should be some sort of arc. Yeah.
Oh.
This area.
Yeah.
If we know about theta and r, what would be the area?
R theta.
Mm-hmm.
Right.
R theta is the length over here, but how about the area for this one?
R
theta is the
arc here,
okay.
So
area here, over here.
So the circle, or the area. Okay, yeah. So circle is pi r squared, right? And then
This
if
one,
you're only getting that angle, so pi r squared divided by theta. Wait.
What would be area? Yeah. Give you some time, okay? Don't
Okay,
rush.
sorry. I don't remember.
You
It's
don't
been
remember. Yeah.
long.
Okay, the reason why keep thinking, okay? The reason why I give you these different idea about area is because that area is a quantity in mass, right? Area is a quantity in mass, and today we are learning computer science, right? So we are trying to write program that actually calculate the area. So we need to know what? We need to know the core computing knowledge that actually is mass. Is that okay?
Wait, I think I got it.
Yeah, you got it.
It's
So what's that?
pi r squared theta over 360.
Pi r square
Theta times theta over 360.
Okay.
And then I did the proportion because
Yeah,
you know
proportion,
pi r
yeah, good.
squared is
But actually, this one, because your theta is in degree, okay?
yeah.
But if your theta is in radian,
Oh,
that will be half r theta squared.
yeah.
Yeah?
That's
And
familiar. Yeah.
It actually is like this. Your radius is this one.
Yeah.
Your base arc will be r theta. So it's just like your triangle, you have half base times your height. And that will give you half r theta, r square theta. Is that okay? So when theta equals 2 pi, you got a pi r squared. Is that okay?
Yeah, that makes sense.
Yeah. So basically what I'm trying to say over here is like teach you through the computing, we really need to know about the essence of the computing. That's why this course I call it Python Programming Essentials. We go into the core of the computing. That's called essentials, the essence of the math, the computing, that would be math. So we learn computer science, and basically we need to know about math, how to do computing. Is that okay, everyone?
Yep.
Yeah?
Yep.
And if you don't know about math, you are actually not able to write any program, okay? You will not be able to write any program. So here actually computer science, what is computer science? Computer science is something beyond math, okay? Your math is used for modeling. So you use your math to model the stars, right? Astronauts, astrophysics, right? You are NASA engineer. You try to use math to model every star, every planet, everything in the sky. And that actually is giving you some equations, some pi r squared, some ellipse equations, some g times m1 times m2 divided by r squared. Whatever typical mathematical equations, right? And we don't care right now, okay? We don't care that kind of complicated math model. But we need to know about the world by using math to do modeling, okay? So quantum computing, we use math to model the quantum. And we go to stock market, we need to track the trend for the stock. So it go up and down every day. We actually go to bank, we deposit money in the bank. Every day we see our savings go up because they give us interest, right? And these different things, no matter it's money or it's actually physical quantity or it actually is a water flow or whatever things, it need math to do modeling, to model the data. And we as a computer scientist, we try to use that math model to write program to create data, more data, and make decision, right? Whether we trade stock or we don't trade stock, we buy a house or we don't buy a house, right? Is that okay? All right, Jonathan, Is that okay, Jonathan? Hear me? So you in the future you may go to college, right? And you may study in high school, and you may do a lot of things. And we learn computer science because we want to solve problems, okay? Because we want to solve problems, so we need to learn math and then use computer science to solve those problems, okay? And in the old days, say 30 years ago, when I went to college, right? Computer science is kind of a middle field between electrical engineering and the math. So math basically model problem, and electrical engineering build computer to solve a problem. So at that time, people thinking about electrical engineering and math have a happy marriage, and the child is this computer science. Okay, so we grew up in such kind of a world, but nowadays it's totally changed. It should be something like this. Okay, so you need to learn more knowledge to learn computer science. Is that okay so far? Any
Yep.
questions so far? No? So that actually is my introduction of what is computer and what is program and what is computer science. Okay? So a computer science is using computer to solve problem, right? Before we can solve problem, the first step is we need to use our math, our language, English, to model the world, right? And then we use that model to solve problems. So first problem I ask you is, what is area? We have all kind of area for different shapes, right? And these different shapes, we need to calculate area. So we need to understand what is the fundamental rule to calculate the area. Is that okay? So here, let's see. So Jonathan, let me ask you a question, Jonathan. For the area that we talk about so far, which one you have learned and which one you have not learned so far? Have you learned the square area for square? Jonathan? Because you are younger as well. Hello? So later I know that what math you have so far. Jonathan, can you answer me? Hello? Hello, hi Jonathan, where are you? Can you answer me what math you learned so far for the area? Okay, I actually later I'll talk to you later. Okay. Anyway, here we have we are going to talk about the computer science. So we go into the chapter 1. Objective. We are going to understand and actually know about what is the software and hardware in our computer system, because we need to rely on them to do computing, right? And then to learn computers, what computer scientists do, and the technique they use to solve problems, okay? And chapter 1 to 4 is a very easy run. So chapter 1 to 4 give you very basic knowledge. So very basic knowledge, okay? Chapter 5 to maybe 10 are actually normal programming topic, okay? 11 to 13 are a little bit tougher, okay? They are a little bit tougher. So if you learn all of these, it is as good as your AP Computer Science A, okay? Actually quite challenging, okay? But I'll try to help you to learn it step by step, okay? So we will actually understand what will be the basic design for modern computer, okay? Actually is topic for chapter 1. So first one is like understand the form of and the function of a computer programming language, and design some using Python language, okay? And to learn chaotic model and their implication in computing. So these are actually written down in the textbook. So we are going to have a detour here, okay? So I'm going to bring up the PyCharm, okay? I'm sorry, I'm going to bring up the idle, the easy editor for a program, okay? So here, first one, let's actually do this one, okay? Here, let's try to write a program that will calculate a the rectangles area. So that actually I will give you the example and I will see everyone to write a program, okay? So the first one, that's actually bring up your idle. So you have an idle maybe on your desktop. So bring this one up and then new a file, okay? So here I will say width equals 3. I have a typo, okay, sorry. And height equals 4, okay? And area will be equals width times height, okay? And then print area, okay? I'm going to start with a very simple example, okay? So let me actually save this one. Because some of you are younger, so I actually will make sure they know every step, okay? So I create a directory called idle. Okay, usually every time we create a program, we save it to somewhere. Okay, so right here, let's create usually I create a name called PyDev. Okay, I'm sorry. Here, let me just put chapter 1. Okay, chapter 1, and here I call it rectangle. Okay, so we use Python. So here I finish editing the program and let me actually run it. Okay, you will get 12. So that's the answer I got. Okay, so now let me actually start from Helen. Okay, Helen, you are younger, so let me guide you step by step to write it. Okay.
Okay.
You share your screen, and other students watch how Helen build the program. Okay. So if possible, please show your head so that I know that where you are. Okay. I'll show my head as well. Yeah, bring up your idle. You know where your idle is, right? On the corner, yeah, that one. And you go to File, New a File. Left side, there's a file, New, yes. New a File, okay? And then save this one, File. Click File again, Save As. Yeah. Okay, and you click your C drive, Windows C drive. Windows, yes. Go to the C drive, okay? Let me see, you may have a D drive, so let's click your this PC, please. Click your this PC, okay? So your this PC actually, can you scroll it down a little bit? You look like you have a D drive. Double click on your D drive, yes, D drive. Okay, so every time we bring up the idle, you actually should, yeah, here you have PyDev, okay? So here you have chapter 1. So stay right here, you type rectangle, so that's your program, okay? Now you start to write the program. WIDTH with WIDTH equals some number. Equals some number. Yes, whatever number you like. Yeah, change line. HEIGHT. Height, right? Equals some number, please. Yeah, other student, please work on your own version, okay? I'll check your program, okay? I'm going a little bit slower right here, okay? So I can check every student's progress. Yeah, change the line, please. And you type area equals width times height. Yeah, times. Time is a star. Star is shift number 8. Shift number 8. Yeah. And height, HEIGHT. Yes. Change line. Print area, please. Parentheses. Put parentheses. No, after the print. It is a function, so after print, yes, put parentheses. left and right parentheses. Yeah, in the parentheses type area. Yes, go to click run. Click the top bar. You have the top bar. Click run. R-U-N run. Click the run module. Yes, go. Click OK. Your line 3, your height not defined. Go back to your program. You type the height as uppercase, but it should be lowercase. Go back to your program. Your program is background window. Here, your program is on the background. This one should be lowercase. You type the height uppercase. Wait, don't move. Okay. Is that okay, Helen?
Yes.
And do run module, okay? Okay, whatever it is, look like it's okay. So next one, I think James, please. So I stop sharing, so let me look at James, okay? This part very easy, but we get started from easy part, okay?
I'm sharing my screen right now.
Yeah. And Ethan, I know you know better, so you write whatever area you want to have, okay? Is that okay? Ethan, you hear me? You write whatever area program you want, okay? I'll check it later, see what kind of area you can calculate. Same for Roy, okay? You guys may know more, so try to calculate whatever area you can. If you can calculate the area for 15 lateral polygon, that actually also okay, up to you. Yeah, then James, you need to calculate area. Area is height times width, right? Time is star, yes, space.
Oh, 1 second. I didn't spell height right.
Yeah, typo, yeah. Take your time, don't worry, okay? I'm not rushing you. And then print the area. You did it the first line, you have 2 area calculation.
Area equals, oh, whoops.
Yeah, you have 2 lines, okay.
Print.
So print parentheses, put area in there, yeah. So now your program, yeah, wrong module, please. Yeah, save. Okay, whatever, it actually work, okay? So now let me actually have, let me see. Jonathan, are you there? Hear me? Can you show your screen? Hello, Jonathan. Can you show your screen? Okay, then Ethan, please. Ethan, show your, I don't know where Jonathan is. But Ethan, can you show your screen, Ethan? You do whatever area you want to calculate, okay? Look like you are doing something, but you forget something as well, right? What should be put into the input? Hey, Ethan, what should be put into? Hey, don't delete it. It's good. Actually, it's good. Okay. Nobody say that it's no good. Okay. So what should be put into the input? What is height? Yeah, that's actually okay. But it must be a string. So what should be a string? Yeah, you do double quote, yes. And you really see this one would be a string. So you need to assign that to a variable. Is that okay? So how can you assign this to a variable? So what's that? L equals this. Okay, that's good. So next one, you need to also input the width, right? Yeah, so everybody watch, okay? He actually is trying to create a program that can accept the input, okay? That's fine. Then, no, your X before W and L, you don't have W and L when you calculate X, so that's not right, right? So you need to calculate X and L, W and L after you got the W and L, right? So the first line, please delete it. First line, delete it. It's actually not going to do anything, okay? And look like your alignment is also wrong. You must align, put your, starting of the line. You must delete that, yeah? Delete it. Backspace, delete it. You still have one tab label. Delete, backspace. No, you delete L. L is okay. You actually type backslash. Okay, here, let me help you, okay? Look like you have not practiced for a while. You are much better before, okay? You got to practice. Don't wait for people to tell you to practice, okay? Hey, wait. Okay, so you got these two things, right? But these two things, actually, they are not numbers, so you need to convert them back to, say, float, 14-point number. And you convert the L to 14-point number, and then W also equals 4. Okay, otherwise they are strings. Okay, then you print your W times L. Okay, and before you print your W times L, you need to print something. So that's what we actually accept input and actually print it. Okay, so this one actually we finished that. So we actually do save all, and we do run. You actually need to run this program. Okay. As for input, so here I say 3, height is 4, so you got area 12. Okay, so here this one is not printed, so I add a colon space. Okay, so I do run. Same thing here, I put 3 and 4. Is that okay? Okay, now you are done. Okay, let's have Zoe. Okay, so same thing, do whatever you can do. Okay, Zoe, your turn. Please share your screen.
Mine is still loading because my
Still
computer is slow. Yeah.
Oh, okay, okay. Yours computer slow, but next time please try a faster computer. Okay.
Okay, I'll try.
So anyway, here we have the first program actually calculate width and height in this way. Okay. So the next one, I'm going to create another one. Here, I'm going to calculate the area for a triangle. Okay. So let me actually create a new program that actually save for triangle. So let me save as calculating the triangle. Okay, so I have a triangle .py. So here I should have a base. Okay, I need to get a base, right? And I don't know how to write a base, so I put a sharp sign. So this sharp sign actually is what? Comment. Okay, so whatever you put after the sharp sign, it is useless. We call it comments. Is that okay so far? Hi, Helen, is that okay?
Do you want us to start a new file? Do you want us to start a new file?
Yeah, you can start, but you can follow or you just listen. It's okay. Yeah. It's okay?
Yes.
You just follow, it's okay. I will give you video, and after class, you can type it again, okay? So this just a comment. So comment means that it's useless. Is that okay? So after the comment, you basically can type whatever you like. Okay, actually, but you run the program, it totally take no effect. Is that okay? It totally take no effect. But if I don't put it as a comment, say, then I actually delete this one, right? I don't put it as a comment and I run it again. You will be in trouble because actually it said that it actually is not the right data. Is that okay? So that is not okay. So anyway, here we have a base, and this base equals, we would actually get the data for this one, right? So before we get this data, we actually should have a base string. Okay, so this base string will get input from somewhere, and I say the base of a triangle. Okay. So I enter something called input. So this input actually would be a prompt. It is a prompt, okay? Asking for data, okay? So this actually asks for data, and this data will get a string, okay? A string is actually a message, okay? You get a message. So this message, we need to convert it to number. So I do convert it to integer, okay? Int means integer, so I convert that to an integer, okay? So this one x for a base for a triangle, and I convert to the integer. The next one I'm going to do actually height. Height string, okay? Also a string, so input. Okay, so I got a string that actually is a height. So here I actually also convert it to a integer of height, okay? Okay, so I get two numbers. So first one, I get a message, right? And the second one, actually, I do what? Convert the message to a number. And that number is integer type, okay? Whole number type. So here, same thing, I ask for a height, right? And here, actually, I do convert the message to a number again, okay? So I got two numbers, and then one is base, one is height. So I'm going to calculate my area equals my base times my height, right? And need to divide it by half. So this one, actually, when you do divide by half, this one, it follow the so-called what? The parentheses, right? Exponent, right? Multiply, division, add, and subtract. Is that okay? You follow the rule. This is a PEDMDAS rule. Everybody okay for this one?
Just a quick question. What is
Yeah.
base? What does the base str mean? What does the str mean? Does that mean string?
str means it's a string. It's a message.
Okay,
So what happened is like this base str, when you do input, right? It really get say 3, 4, 5, but that's later. That actually is later. Is that okay?
Yep.
That's later. So this later, it actually we call it string. Then we need to convert this one to a numbers called 3, 4, 5. So this integer converted to integers. The int converted to integers, and it become a number. So the number you can do plus, minus, and divide. But string, you cannot do that. Is that okay?
Yep.
So you need to ask for a string converted to a number, ask for a string converted to a number. Any question here?
1 second. I'm not done writing the code yet.
Are you okay?
What's Pandas?
So far, okay?
Yup.
Yeah. Any question so far?
I'm not done.
Yeah, take your time, okay? I'm not rushing you, okay? I know this is the first lesson, so don't worry. I'm just going through the writing program, right? Give you the idea. Today, our topic is area. I just go through different area, right? And I have not introduced the language structure yet. So I just give you some sense of what is programming, okay? So don't worry about the input, integer, whatever. Later, we are going to teach you, okay? Any questions so far? So first thing is that you must know about is a PEMDS, okay? It's a parenthesis, okay? Exponent, right? Exponent. Then multiply.
Yeah.
Multiplication, okay? And then you do division, okay? And then you do addition and subtraction, okay? What this really means is like when we write the program, right? It's left to right, and then higher priority operator first, okay? So it's something like we will do base times height first, and then we do divide by 2. So base times height, the result would be calculated with divide by 2. Is that okay? Okay, that's the rule. So here, if we do e star star 2, that means e to the power 2, okay? And then times 3. So this one really, it means e to the power 2 times 3. So it's something like this. It is not e to the power 2 times 3. That actually would give you 6. E to the power 6. So actually it's not this one, okay? So if you want to do e to the power 6, you need to do parentheses. Otherwise, you will do this e to the power 2 first, okay? Some of you may not learn the exponent yet, but I just use it as an example here. But don't worry, we will go back to the functions later, okay? Any questions so far? So Roy, you have any question? You can ask me question, okay? Don't worry, I'll actually answer you. Any question so far? Hello?
Nope.
Roy, you have question?
No.
Yeah, you have question? Yeah, Roy.
Yeah, I have a question.
Yeah, you
So
go ahead.
my program is working now,
Yes.
I think. And then how do I don't know how to put in the real numbers.
You don't know how to put real number, okay? So let me finish this up and I will go to help you, okay?
Okay,
Don't worry.
you.
So the next one, let's just do print. And then here I put triangle area colon. And here let's put area over here, okay? And this one, let's actually save and then run it, okay? So here I'll ask for the area, the base. So 3 times 4, you got 6, okay? Now I stop sharing, you share, okay? You share your screen now. So I try to teach this course more interactive. So if you have questions, you let me know, okay? And I will turn to you to help you, okay? So you share your screen, please. More participation will help you, actually, okay? Yeah. Roy, can you share your screen?
Yeah.
We haven't seen your screen yet.
Okay. Wait a second. Oh wait, this is not right. Okay.
Yes. So
Yeah.
here, you kind of jump too far to this. I would rather you use idle. Is that okay?
Oh.
This one actually too far away. It actually, I mean, it's okay. It's a good program, but actually, you kind of jump too far. It's too difficult for you for this moment. Can you try to use your idle? You know idle?
Yeah.
Last time we installed it. Okay, get started from there first because using PyCharm, there are a lot of extra work you need to work on. That will distract you from learning Python. Is that okay?
Yeah. So I don't make a new project. I just go to idle.
Yeah, just go to the idle. You can still get it. Okay.
Okay.
Same program can be opened by idle. So you bring up your idle and share it on the screen, and I'll see it.
Okay.
Are you okay? Look like right now you are
Wait.
sharing only the app. You are not sharing the screen, so I cannot see. You are sharing only the screen, the app. So I only see your PyCharm. I did not see your uh,
Oh.
idle. You know what I'm saying? So
Yeah.
you need to stop sharing and reshare again.
Okay. Okay.
Let me stop your sharing. You reshare again, but share desktop so we see the whole picture of your computer. Is that okay?
Okay. Okay.
It's okay. First few times get used to Zoom. That's actually normal, right?
Okay.
Okay.
Wait, is this right?
This is right. Let me check your environment. Okay, don't worry.
Okay.
So let's actually give me your control. Okay, first thing, let's actually minimize the PyCharm. Okay, this one is too cancel. Okay, let's minimize the PyCharm. We keep it there, but we don't need it. Okay, so PyCharm, let me minimize it. Okay, this one is minimize it. So the idle is over here. So you don't need to search for idle. It's the idle program is over here. Double click this one. Is it okay? This one. The idle is over here. Your computer program idle is over here. Okay. So now we bring out the idle, then we are looking for the program you have. Okay. So here we do file. The same program can be opened by PyCharm and also by idle. So first thing I need to go to your D drive. Okay, your D drive look like it's actually that's F drive. I'm sorry, could be a camera or something. Okay, I have the low okay, and PyDev. Okay, so chapter 0. You don't have chapter 1, so you write a program, right? So let's rewrite it. Is that okay? Let's rewrite it. So here, let me actually create a new directory. Okay, so here let's type ch1. Okay, so under ch1 here we do we just do triangle. Okay. Now the first day it might not go as smooth as we want. Okay, but don't worry, it's the first time. Okay. So we do create a triangle. Let's actually do new one. Okay, so create a new one. So every time you create this one and you do save as, okay, go to your D drive, go to, no, not video, go to OA, okay, go to here. Somehow your computer still not really that fast, okay. Okay, here we have this one, right? I try to be quick, okay, so I say base string equals input, okay, and here I do like this one for base, okay. I just try fast, okay, so I don't type the whole thing, and then base will be equals integer of ps, okay, and then we have height string will be equals input. Okay, the variable name actually doesn't matter. Okay, we call it BS, call it HS, actually doesn't matter. Okay, so we have the height. And the text, whatever you want to call it, you can type a lot of things that actually doesn't matter. Okay, so this one we have the height equals integer of the no, HS. Okay. Okay, then we calculate area, and the area would be the base times height divided by 2. Okay, and we print the area. Okay, that's it. Okay. So here they ask number, right? You type it in, okay? Type 3 here. And then hit enter. And then type 4. Hit enter. Okay, so what happened is like right here, you do input. That input export 3 here. Is that okay? So it's like base, you type base. So here if you say, give me a base, you will type, give me a base. Is that okay? Hello, Zoe, is that okay? Hello, okay. Then hide
Dr.
the
Chow,
sentence. Yes? Question?
I think there might be something wrong with my program.
Okay. So yeah, so Zoe part is okay. Let me switch to James, okay? Thank you, thank you. So next one, James, please.
Dr. Chow.
Mm-hmm. Yeah, okay. So James, this one is yours, right?
Yep.
Wrong.
When I ran it, it did not work. So
It worked, but you did not print it out. You calculate everything, but you did not print out your area.
okay,
Well,
so
you need to do print, PRINT, but start from the, yeah, parentheses, yeah, area, yeah, you need to have that, yes. And you click run, yes.
so
Yeah, so you work, right?
okay, yeah, it works now.
Yeah, you work. Now Helen, please. Hi, Jonathan, how are you?
Good.
So next one will be you, okay?
Okay.
Let's look at Helen, okay?
When I press run,
You show your screen. Yeah, show your screen so I know what you have. You show your screen so I know what you have, okay? Where is your program? No, where's your program? You're idle. You're idle. I need to see your idle. I don't need these.
I don't know what it's
Jonathan, is that yours? This one yours? Jonathan, is this window yours right now?
I don't, yeah, that's one window. I don't know where's that.
Yeah, take your time, okay? Don't worry. So this Outlook, is that yours or is that Helen's? Hello?
Hello.
Yeah?
Yeah, that's not mine.
This is not yours, so that's Jonathan's. Okay, that's okay. So let me help Jonathan first. Is that okay?
Yeah.
Since we are on his, okay. So Jonathan, give me the control, okay? Click yes, okay. So this one, let me actually close it, okay? Jonathan, don't worry, okay? It takes some time, so let's do it, okay? So here, when you ever get started in your environment, right? First thing you do is you need to actually start from this idle. Is that okay? See the idle here? Double click it. Okay? So you bring up the idle. Okay, that's good. Okay? Next one, let's do this one. Here, click the file here. Click the file here, please. Click the file here. New file. New file. Yes, new file. Okay? So this one, click the file for again. Click the file again. Click the file again, please. Yeah, you can type print AAA, but AAA have no value. Hi, Jonathan, can you click the file first? Yeah, save us. Save us. No, not open. You cannot open anything. You don't have file. File, save us. Save us. Yes. Okay. Now wait for a moment. Okay. Now I'm going to control it. So you save us. Not yet. Not yet. Not yet. Don't move. Don't move. Okay. You have a SSD, right? Let me look at it. Okay. One moment. Okay. Don't worry. So you have SSD, right? You have user. Last time we have a Jonathan fan over here, right? So you have your program over here. You have many things over here. Let's try. Okay, one moment. Let me take a look on it. Okay, you have your SSD. I think it's under your Jonathan. So SSD Jonathan. Here you have PyTech. Okay, you have PyCharm and test. So right here, let's create something called idle. Is that okay? So put into the idle, okay? And right here, actually, let's create something called chapter 1. Okay? And after chapter 1 here, let's try you. Let me actually also help you to work on this rectangle first, okay? So we create a program called rectangle. Now you need to read in the number called rectangle. I'm not going to help you right now, okay? So please type something called width, W-I-D-T-H. Can you type it? Jonathan, can you type it? Can you type width? W-I-D-T-H, width. W-I-D-T-H, width, the width of a rectangle. You need to calculate the area for a rectangle is width times height, right? So you type W-I-D-T-H, is that okay?
Okay, still good.
Go back to your program, go back to your program. This is not your program. So go back to your program. Your program is right here. No, not this one.
Still EH.
No, it's not your program. Your program is in the editor. You must find your editor here first. This one, yeah. Over here, you type W-I-D-T-H, please. Okay, so here let's do W, okay? Let's just do W. Yeah, W-I-D-T-H, you type it.
Y-W-E-H.
What?
Y-W-E-H.
You type width, okay? W-I-D-T-H, width equals. You do input, okay? And here you type in the width. Okay, and here we do height, okay? Height will equals input, okay? And here we have HEIGHT, okay? And you get the input for width and height, but your width actually is a string. So here we need to convert it to integer, okay? So we do int, okay? And convert width to it, okay? So this one is not minus, this one should be equal, okay? Okay, here we have height, so our height will actually equals input of the height, okay? So you put a string into the input function and get it back to the same variable name. It is okay for Python, okay? It is actually okay for Python. So here we get the area would be the width times height, okay? So print the area. Jonathan, is that okay?
Yep.
Can you hit the wrong module for me? There's a wrong. No, not here. Hit the wrong. No, don't delete it. Put parentheses. Yeah, there's a wrong up to the bar, file, edit, format, and wrong. Hit the wrong for me.
Wrong.
Wrong, R-U-N, wrong. And then there's a wrong module. Hit the wrong module. Yes, click it. Is that okay? And okay. We put 3 in there. 3. Put a number 3 there. Yeah, hit return. Hit return. Return, you know where is the return? Can you hit the return for me? Hi, Jonathan, hear me? Hit the return for me.
Return.
Yeah, return.
Where's return at?
Return is above ship. Return is this mark. You should see a ship. Okay, it's on the right side of your keyboard.
Oh, shit.
Hit the return, please. Enter, yeah, it's also called enter. I put a 4, please. It will be wrong, but anyway, hit a 4, okay. 4. Number 4. So actually it's called enter. I'm sorry. Actually, it's sometimes called return, sometimes called enter. Hit 4. Hey, Jonathan, hit 4 for me, okay? Are you okay?
Yes.
Okay, anyway.
Enter.
Okay, anyway, your program, you enter the wrong thing, okay? Try again, you come back to here, hit wrong module, okay? So here we hit 3 and hit 4, and you hit something, okay, whatever. Must be focused, okay? So you do wrong module, you hit a 3, and you hit a 4, okay? Then you've got 3. Okay, how come you add for 2? Let me actually go back, okay? Something wrong with the program. No, I'm sorry. Here should be an integer. Okay, convert it to integer. It actually is wrong. Okay, I made a mistake. Okay, actually, let me save again. Okay, and I do wrong again. Okay, wrong module. So here I hit 3, hit 4. Okay, Jonathan, is that okay?
Yeah.
Can I give you the calculation for area? Okay, you practice it. Okay. Now I go back to Helen. Okay. Now Helen, your turn.
Okay.
Helen, your turn. You input the base of triangle, you convert it, yeah, to okay. Hit wrong, please. What's wrong with your program? Yeah, you type number, please. You type number. No, not there. You go down to the lower line. Yeah, over there, type 3. Whatever. Yeah, hit return. Hit enter. Yeah, enter. Sometimes I call it enter. It's the same thing here. Invalid literal. Let's try again. Okay. So go back to here, go back to your program, please. So over here, actually, you really want to have a colon and space. So you know where you are going to enter your stuff. Is that okay?
Yes.
After that, you do run module and we save. So here it asks for number. So here I type 5, type 4. Is that okay?
Yes.
Yes? Okay, so that's what you need to do, okay? Any questions so far, everyone? Any questions so far?
Nope.
No.
No question, we are going to continue, new topic, okay? So I'll actually give you some experience of what is programming, okay? And we are going to go into more topic now, okay? So the first thing is we have some sense of what is the programming, right? Next one, we look into what's machine and program, okay? So first one is called universal machine. Okay, universal machine is the machine that you are working on right now. It's called a universal machine. What is non-universal machine? What is a non-universal machine? Okay, we are using a personal computer, Macintosh. That actually is a Macintosh, or you have PC Windows. Okay, they are both universal machine. Okay, but something like calculator, TI-84, they are specific, application specific machine. Okay, application specific machine. So it's only used for calculation. Is that okay? Your
Yes.
smart iRobot, right? iRobot, smart iRobot, clean up your room, clean up your space. Hey, don't throw it, okay? So we really run away, okay? Okay, so you have an iRobot that will clean up your room, right? That iRobot actually is an application specific machine. Is that okay? So you may have a cell phone. Cell phone is also considered to be a application specific machine, but nowadays the cell phone is so robust, so it's almost like a universal machine. Any questions so far? Yeah?
No.
No? So you know what is a universal machine. So our PC, our Windows, our cell phone in general, we can call it universal machine. So a universal machine is a machine that can store and manipulate information under the control of a changeable program. Your calculator don't change the program, right? If you have a dumb calculator, you don't have a changeable program. You don't, okay, calculator, no. That's not a universal machine. So universal machine is something that you can change the program. So you can write a program, right? You try a triangle.py program, you write a rectangle.py program, okay? Those kind of program, machine that can run the program for you is called a universal machine, okay? And two key elements, computer are devices. Hey, what's that? Stop it, okay? Okay, computer are devices for manipulating information, okay? Computer operate under the control of a changeable program. So we are a programmer, so we write program, right? And computer will be under the program of the program that assigned by a programmer. Is that okay? So two key components. One is computer, right? You do programming, two main elements. One is this computer, right? The other one is the guy who sit over here to write a program, right? And he write a changeable program. So there is a software from the hard disk loaded into your computer. So that actually is the program. So two things are important. One is the program, one is the computer. Is that okay?
Yes.
That's what we are going to teach you in chapter 1, okay? Hi, Jonathan. How are you?
Nice.
What is computer?
A computer.
Mm-hmm.
Computers are devices for manipulating information.
Good. So what is a
Control of a
program?
changeable program.
Yeah, what is a program?
Like AI and double E and stuff.
Okay. What is a game?
What?
What is a game? Video game.
Mm.
Can you define the video game for me?
No, I can't.
It's
I
not
don't.
on this slide, right? It's apparent. It's not on this slide. But what is a game? A game is also a program. Okay. Jonathan, is that okay? Game is a program. So
Yeah,
game
okay.
is someone who write a program for you. So you buy a Xbox 2, right? You buy a PS5, right?
Mm-hmm.
Those are computers as well, right? People do programming on the PS5, so they are also a computer, and they buy some software, say League of Legends, right? They buy some programming like Doom, right? Whatever game. Those are programs, and you can load those programs to your Xbox 2 to play it. Is that okay? So you play game before or no? Jonathan, you play game before or no? You have Xbox, right?
Mm-hmm.
You also have PS4, right?
Mm-hmm.
So PS4 have a game called Doom, and also Xbox also have a program called Doom. So Doom is made to be platform. It can play on two platforms, Xbox, or you can play on PS4. Is that okay? Is that okay? So programmer's job is to build hardware or software. You build software. That's a programmer's job. Programmer write the program Doom, but computer builder build the Xbox 2 or PS4, or maybe your PC as well. The same game can also be written in your PC as well. Okay? Is that okay? Hey, don't do that. Okay? Don't do that. So your PC also actually is a platform. Your Windows also a platform. Doom can also be ported to there. Is that okay? Is that okay?
Mm-hmm.
So Roy, you got this idea here?
Yes.
Yeah? Let me ask you a question. So you are music major, right?
Yeah,
So
yeah.
You put your program over here, you have a game, say this Doom game or Duty of whatever. There's a game called
Call of Duty.
yeah, Call of Duty. Okay, so there's a game called Call of Duty. So Call of Duty can run on PC. They can run on also on Xbox 2. They can also run on many machines, right? So that is a piece of software that we know, right? So you consider your music piece a part of program or not? Yes or no?
Wait, music piece is part of a program?
Yes or no?
I mean, I've composed music using like app like Finale, which is a program, but
yeah. So you do, say you do Super Mario, right?
oh
And
yeah,
if you are dead, they give you a game over song, right?
yeah.
Yeah. So
Yeah.
music is one part of the program. Is that okay?
What? Yeah.
Yeah. So then it's the same thing. Image or video, is that part of the program or not?
An image.
Image.
I think. I mean,
So
a
someone takes
program.
some beautiful picture and put into a game, right?
Yeah.
That also is part of
Yeah,
the
yeah,
program.
that's part of the program.
How about graphics? You design some graphics. Say you put a Call of Duty, there might be some people, right? You use your hand to draw it and it become an animation. So is that part of the program or not?
Yeah, because it's
Yeah, that
all
also-
it's all part of.
Yes,
Yeah,
they are
yeah.
all part of the program. So a program, you have a game engine. You have a game engine, right? So this game engine control of your image file, your music file, your video file. Hey, Jonathan, please stop it, okay? Okay, so your game engine actually is a program. It may be written by C program or some C++ program, but they control everything here, right? And before you design this game, you must have a scenario. you try to have a story, right? Is that right? There's a person, he go into a door, right? And then there's a machine gun shooting him, right? Is that okay?
Yeah, yeah.
So this is a
Yep.
story. We need to write this whole scenario into a program, and that can be run by the game engine. And that game engine actually also call your image file, music file, and video file. We integrate everything into a program, and that program being sold into a CD-ROM format and sell to other people, and they buy it from, say, Walmart or somewhere, and they get that CD-ROM installed or download from internet and install on their Xbox 2, and they play it. Is that okay? So that's the whole hardware and software industry. So you do music, yeah, that's great. You do some art, you draw something, that's also great. They are also all part of our program. Is that okay?
Yeah, yeah.
So it doesn't matter you actually do which part, okay? You can work for Disney and they create some program and they need music, and they may be some other programmer who do C++ programming and write a game engine. They may be a person who is major in history, and he wrote some story, and we come up with the scenario, and those scenario we implement into some acts, some scene, some stage, and we put them into our game. Is that okay?
Yeah, yeah.
So
That makes
game
sense.
industry is a big industry. It need all kind of people to put into there. Okay, so that is actually is a computer program, and our job is to learn from very basic program, just from calculating an area, drawing a triangle, drawing a rectangle, and start build up one by one, until we are able to design a game. We can design a iRobot, we can design a something more advanced. Is that okay? That's what we want to do, okay? That's what we want to do, and we are in the lesson 1, okay? So Hayden, is that okay so far?
Yes.
Yeah? So your program got executed, carry out, okay? We call it executed or carry out. So our job today actually is doing what? We do writing some recipes. So step 1, we take our base equals some input something, right? Step 2, we do our height also equals some input something, okay? Step 3, we convert our base from a string to integer. Is that okay? Step 4, we convert our height also from a string to integer. Step 5, we calculate the area equals my actually base times height divided by 2, okay? Step 6, actually we print out my area, okay? So that actually look like a recipe, look like some menu, or look like something, some article. We call it our program, okay? We call it our program. And this program being loaded to our PC to run, okay? So the PC actually is the hardware, right? And our program is software. So today we are talking about computer versus program. It's hardware versus software, okay? Without hardware, you cannot run your program. Without software, you cannot control your computer. Is that okay? Any questions so far?
Yes.
And your program got controlled step by step, okay? Your program got controlled step by step. So to put this program together as a recipe or as a program, this activity, we call it programming. Is that okay? The activity to write a program step by step, one by one, putting them together as a executable program, we call it programming. Okay? Ethan, is that okay, Ethan?
Yeah.
Yeah? So our job as a programmer, we put them together one by one, okay? And computer scientist is a little bit above the programmer. Programmer just write a program. Computer science, you need to build a math model and then put them into program and then get a result and show them to people, right? So computer scientists are actually have more job, okay? Not just doing programming, okay? So we actually run the program, we carry it out, and all computer has the same power with suitable programming, okay? So nowadays, every universal machine almost can do the same job, except that one is faster, one may be slower, okay? So you buy best program, best hardware, just to make sure that your program runs faster, okay? So program power is including the software, how fast your software is, also how fast your hardware is, okay? So we measure the size of the program by how many transistors on board, okay? So to do that, actually, let's look at it, okay? Let's look at the modern day computer. So we know that you open a computer board, okay, and we will see something like this, okay? We'll see something like this. So these are actually a computer board, okay? Let me try to get something here, okay? Let me don't call it computer board. Let me actually search by motherboard, okay? So we have a motherboard. So here, let's see. Let me get a more typical motherboard. So let's look at this one, HP computer motherboard. Okay. Okay, so here we have a motherboard. So your computer have a motherboard. We call it motherboard because it had many things on it. Okay, and here these are actually slots, memory slots. Okay, so you can put your DIMM memory, dual in module memory. Okay. That actually you can put your DIMM module, the DRAM in module, so that actually has a card put here and you have DRAM on it. This kind of card we call it daughter board. Is that okay? Mother and daughter. So that's daughter board. Okay, so that actually is called daughter board. So daughter board, we can also search for it. A daughter board is look like this. Okay. A computer including the motherboard and daughter board. Okay. No, not daughter. We look for daughter board. Okay. So daughter board usually is something like smaller like this one or like this one, and usually is like memory. Okay, so memory card like this. Okay, memory card like this that can be inserted to your motherboard. That's called daughter board. Is that okay? Hello, is that okay?
Yup.
Okay.
Yes.
So that's daughter board. Okay, this one is a NEC daughter board. So daughter board being plugged into this slot. It's a HP machine. Okay. And that actually is our memory slot. CPU is this guy, right? So how fast your CPU can go is this guy, right? That guy is called CPU. And how comes that it has the metal cover? What's the metal cover for? Zoe, why it need to be covered by the metals?
That's the most important part, right?
Yeah.
Is it?
Yeah.
Why
we need to cover by? Why we need to cover by metal?
Because you need to protect it. Otherwise, it
You need
might
to protect.
get damaged.
Yeah, purpose one, you need to protect it against the EMI, electrical magnetic interference. Is that okay? Metal can shield the CPU, so metal outside you will shield it from the EMI. Is that okay? That's number one. Number two, metal can faster dissipation. So it also is a heat sink. Is that okay? So your CPU burn power, it has heat. You dissipate the power heat away. Is that okay? So here you have another processor, right? And that one has such a kind of the heat sink. Is that okay? So actually, you put a metal bar there just to maximize your area of exposure to air. Is that okay? So when the processor actually become hotter, right? Temperature go up, you will dissipate the power away. The heat will go away. because you have that heat sink. Is that okay? Okay, so that actually cools things down. Okay, so a motherboard including a CPU and memory, right? And this one look like is a bus I/O, a bus arbitrator. So your program actually may be hooked up from the so-called SATA or hard disk controller. Okay, so it actually may have the IDE or SATA actually connected to your hard disk. Okay, so your program got loaded from hard disk to your memory, right? And memory actually load the program to your CPU to run, and then after you get the result, you actually write back to memory, and the memory may be picked up to your hard disk again. Is that okay? And then you may shoot me an email. So here you have Ethernet connector. So here Ethernet, your email send out the program file to me. Okay. Here you have USB, right? USB can control your mouse, whatever. Here you have your so-called PCI Express. So you connect it to your monitor. Is that okay? Your program monitor. Is that okay? So that's roughly the computer hardware you have. Okay, so every computer you can open the box and you will see something that is. Hi, Jonathan, is that okay? Hi, Jonathan, is that okay? Hear me? Anyone want to become a computer hardware engineer to build a computer for people? Anyone?
Ethan does.
Ethan does? Okay. And
Maybe.
in fact, maybe, okay, maybe. Actually, hardware engineer is a good job as well, okay? So working on computer, you either become a software engineer or you become a hardware engineer, okay? And writing a game is also a software developer, but it requires a lot of knowledge, okay? So playing a game and actually writing a game are two different things. You write a game, actually you need a lot of knowledge. You need to know about your machine. You need to know about your program, okay? To play a game, you don't need that. You just need to be a quick hand, okay? Any question? No? Okay, so basically, here you actually help yourself to become more intelligent user of programmer and actually learn how to do programming, okay? And then actually learning programming also help you to solve problems more systematically. So computer programming is a very fun task, okay? Okay, that's actually our first part. Second part is what is computer science, okay? It's not study of computer. Computer science is not study of computer. Computer science is using computer to solve problems, okay? So let's see. I will ask Zoe, okay, because you are you are college student. What is actually science?
Wait, what is science?
Mm-hmm.
Science is observation. It's the study of you just like science is like how it's like a way to answer questions. Like if you have a question about something, you have like the scientific method.
Yeah, okay,
all
good.
that, so.
How about what is biology?
Biology is study of life, or like living creatures, or plants.
Living creatures, okay.
Yeah.
How about what is chemistry?
Chemistry is study of not atoms, but like matter and like the quantum, wait, no, not quantum physics, but it's like just like what stuff is made up of, and then like chemical reaction.
Yeah, okay. What is physics?
Physics is the study of motion, not motion, like it's like, yeah, I guess it is like gravity and yeah, forces.
Good, okay.
Yeah.
What is data science?
Data science is study of data. No, it's you have like isn't it like how you like organize or compile information?
Okay, and then there's a guy who called financial science. Is that possible?
Sure, the study of finances, or like, money.
How about another guy called environmental science?
Oh yeah, I took that in eighth.
Yeah.
Yeah,
So
study.
why is that?
It's like study of the environment, like soil and the earth, and like how much like air might be in the water, or like if the water is.
So there is another subject,
healthy
eighth grader or seventh grader took. It's called Earth
Earth
Science.
science. I remember.
What was the difference between these two?
Oh, Earth is like you learn. I mean, it's similar, but Earth is more like Earth science.
You study
like
rock?
planet. No, yeah.
You
I
study
mean,
rock?
no,
You
Earth science
study
like
water?
I mean, wait. Let me think. It's like the outer core, inner core, like Earth, like It is similar, but environmental science is more focused on, like, I think like precipitation or like. Earth science is more broad.
Earth science is more broad, yeah. Environmental science can be considered part of Earth science. It's more like talking about humans' environment, right? Whatever human made or human manage or something. Earth actually natural or human made, right? So actually more like rock is part of it, right? Water part of ocean part of it. So it's a little bit different, okay? And then, okay, why am I talking about these so many different science? And what is computer science? Let's go back to here, what we want to do, okay? So this question, let me ask you, your little brother, okay? Ethan, you are actually genius, okay? Now, what is science?
What is computer science?
What is science?
Science is just you study like why stuff is stuff.
You study physics, right? So physics is one of the science. Then what is actually science?
It's just like studying.
Answer questions.
It's like answering the questions.
Yeah, actually, these questions, what is science, is not easy, right? It's actually not easy. So let me turn to James, okay? What is James? James, what is the science?
Science is basically
investigations to answer questions.
investigations to answer questions about the natural. Okay, it's the intellectual and practical.
Don't read it from internet. I don't need it from internet. I just try to come up with your own answer. I actually, it's okay. You know, if I want to need to look at the definition from internet, I can do it. But here I want you to hear your own description, right? Is that okay? Okay, you talk about something like here, yeah, but so this term science actually is not really easy to define, right? So how about Jonathan? You know what is science? Can you tell me? There is something called food science, right? You may be an expert on it, right? Food science. So food also has science, right? Jonathan, you hear me? Hello. So food science may be to study the nutrition and how to prepare food and the food safety, right? Safety. So there are a lot of things that related to food. We actually call it food science, right? They probably also have the gamble science, right? How to actually maximize your chance to win in a gamble, okay? So here I ask you, what is the science? Basically want to know about what's your general sense of what is science, okay? So science, if you study the definition, usually is using a systematic way to actually study something, investigate something, or actually solve some problem, okay? So basically scientific method is using the systematic way to set a hypothesis and to design experiment, and then you collect data, right? And to prove or disapprove your hypothesis, right? Is that okay?
Yep.
Yeah. So every science is the same. Biology, chemistry, physics, data science, everything is you use a systematic way to actually set out the program. So we as a computer scientist, we solve problem. We use our program. So program is our mathematical way of solving problem, right? Right. So we use computer to solve problem. That's called computer science. Is that okay? We use computer to solve problem. That's called computer science. Biology is biological science. So actually use to study the essence of biology or to solve the problem for biology, that's called biological science. Chemistry can be called chemical science. Basic chemistry is something that changes the organization of the atoms, right? If the organization of atom has not been changed, it's not chemistry. It's just physics. Physics, you can heat, you can actually run, you can actually observe its energy, but it won't change the molecule structure, right? Zoe, right?
Wait, sorry, what?
Chemistry is something that changes the molecule structure, right?
Yeah, it can't.
Or the
Depends,
nucleus,
yeah.
right? So
Yeah,
if there is no change in its molecule, actually it's not chemistry, right?
No, then it is chemistry. It's just physical reaction, like from water, solid to gas.
Yeah, the phases are, but if we do not reorganize when we talk about chemical reaction,
Yeah.
right? It really involves the change of molecule structure, right?
Yeah. Then yeah.
Yeah.
Mm-hmm.
And physics actually is what?
Physics is movement.
Yeah. And you may also have
energy.
Electricity, right? So physics mainly deal with energy, right? Physics mainly deal with energy, right? And then to deal with energy, you have three major branches. One is mechanical engineer, one is electrical engineer, the other type is optical engineer, right? There are some others, but basically these are the three major branches. Is that okay?
Yeah.
James and Ethan, are you okay?
Yep.
Yeah.
So you actually Ethan study physics, okay? So physics basically deal with energy. And what does computer science do? Computer science deal with information. Okay. So we get a wave 0, 1, 0, 1, 0, 1, right? That actually is binary data. That actually is for computer science. We look at scene as 0, 1, 0, 1, right? How about the other guy, double E guy? It is an electrical engineer or there is a physicist. He look at this one, 0 volt, 5 volt, 0 volt, 5 volt over here, right? Transition time from here to here, 3 nanoseconds, right? Zoe, is that correct?
Yeah.
So same waveform for computer science to see it actually is 0, 1, 0, 1. Same waveform looked by the double E guy or a physicist. They look at it and they see voltage. They see electrical field change. They see how much energy being spent over here. They see energy equals power equals I times V, right? They do not see 0, 1. They see 0, 1. They are actually computer scientists. So some people major in EECS, electrical engineering and computer science. They need to deal with both. How to represent your data with minimum energy. Is that okay? James, is that okay?
Yep.
So in the future, if you go to college and you major in computer science, you pretty much deal with these numbers, right? 0, 1, 1, 0, 1, 1, 0, 1. We deal with that. If you go to double E, actually you deal with this, right? How many voltage, the electrical field, how much electrical migration will be, a lot of things like that. So we do computer science we do study and we try to understand the computer. We try to use the computer to solve the problem. And the whole thing is called computer science. Is that okay?
Yeah.
So computer science use 0, 1, 0, 1 to solve problem, right? Number representation to solve problem. electrical engineering and the computer science, X, the MIT or Berkeley has the X. It actually is to deal with the electrical property, also with the information. So they deal with energy and information, okay? And the Department of Physics, they deal with energy, okay? They deal with only energy. They don't deal with information, okay? So nowadays we talk about quantum computer. So quantum computer basically is to deal the energy at quantum level, but we present the data at the quantum level with the quantum jump as well. Is that okay? So in terms of the theory is the same. You deal with energy, use the energy, the minimum amount of energy to deal with the information, okay? So Helen, is that too hard for you? The thing that I'm talking about so far? Hello, Helen, you hear me?
Okay.
You are okay? Okay, good. How about Jensen? Are you okay? Hi, Jensen, how are you? You hear me? Hello, you hear me? Hello, hear me? Okay, so this is computer science, okay? Okay, so the design, actually, let me see how far we are, okay? I'll try to finish up to a finish of a section. So let's finish this one, finish the hardware, okay? Finish the hardware basic, we will be done, okay, for today. Is that okay? So basically, let me go back, okay? So computer science, we actually use computers to solve problems, okay? So we need to design some way to solve the problem. So we use our Python to design a program to solve problems, okay? So we do it step by step to solve it, okay? And we need to analyze the program. So we need to know about what is the triangle's area. So we need to know about the base and height, and half of the base times height, that would be the area. And this one comes from, basically you can make the area to be the base times the height, right? And actually you actually do what? Do base times height, that would be the size of the rectangle, and you divide by 2, right? That actually is the area for such a triangle, right? And when we deal with this arc, right, the area for this arc, we say it's r theta. So here you have r, here you have theta, and this length is r theta. But if we really actually cut this one to smaller arc, right? Each individual one here, the length is a small r times theta, okay? And that's r. And this one, we can use a triangle to mimic it, right? So totally, you sum up the whole length for that one, and using the integral, you should be able to solve the so-called pie in the pie chart, the area similar to the triangle area. Zoe, is that okay? Hello?
Yeah,
Yeah.
that's good.
That's the way we use integral to solve the problem, right? You do integral over the theta, you will get that, right? Is that right?
Yes.
Okay, so we do experiments. So some problems are too complicated. Okay, so we do experimentation. Okay, so if you don't believe that area can be calculated in that way, we set up a program, run it, right? And if the error is very ignorable, then we say that it's success, right? So hardware basics. So we look at the motherboard already, and the computer has a CPU, main memory, and input device and output device, and secondary memory. Secondary memory is our hard disk, right? I'll try to finish before 6, okay? 2-hour class. So here we have the hard disk, okay? And you read your program from the hard disk to your memory and put the program to CPU to run, okay? Then you type your keyboard input, and they may show the output to your monitor, okay? So that's the basic hardware chart, okay? So the CPU is the brain of the computer, is in charge of the computing. And I show you the CPU processor in the motherboard. Okay, so we see that. And memory is used to store the program and data. And we have RAM, we have DRAM, and those memory have two levels, main memory and secondary memory. Main memory is the one we put into the motherboard, daughter board, right? The daughter board is the main memory. And secondary memory would be SSD or a hard disk, okay? And input device is our keyboard or our microphone, okay? And output device would be our printer monitor, okay? And a program has the fetch execute cycle. So every time you get an instruction from your memory, put into your CPU and CPU run it and carry out a result, and the result being saved to your memory. Okay, that's called fetch execute cycle. Okay, so basically instruction sets, fetch, instruction decode, operand, fetch, execute, store result. This one a little bit harder, so I don't spend too much time on. Okay. Okay, so today can we stop here? Any question? So
No.
we will be stop here, and for anyone who still have question, you can stay. Okay. So for those of you who have no question, you can leave. Okay, we stop over here. Any question? Who would actually ask the first question?
Is there homework?
Homework, we are not done with the chapter 1 yet. So when we're done with every chapter, here the chapter you have true and false question, right? Today we only up to, we go quite slow. So you can download the slides over here, okay? In the course, there's a slides. You come to here, they are you don't need to take too much note, okay? The whole PDF I give you, okay? And actually I send you the PowerPoint for today as well, but we just finished up to section 1.2. I go pretty slow today, okay? So I will need you to do the homework when we finish chapter 1. Is that okay? But if you choose to write the program, take the true and false question or multiple choice question, or write the program earlier than we finish chapter 1, it actually is also welcome. Is that okay?
Okay.
Okay.
That's about homework.
Thanks.
How about any other question?
Thank you.
Thank you, Heron. Okay. Any other question? Anybody has other question? It's okay, okay? If you have question, you can ask right now. Actually, I can go more time to help you, okay? Anyone has question? No? How about Jonathan? You have any question? Hear me? Jonathan, you have question?
No.
No? Are you okay?
Uh-huh.
Yeah, let me know you have question, okay?
Oh, wait, I have a virus.
Okay. So if no question, I'm going to stop here, okay? And thank you. We'll see you next week. Is that okay?
Thank you. Bye.
Bye-bye.
Thanks. Bye.